Hello dear students, in today's class we are going to study about chemical properties of aldehydes and ketones. Now to study the chemical properties of aldehyde and ketones, let's study the structure of carbonyl group. As we know that carbonyl group is containing C double bond O, and as we know that if it is a aldehyde then we can place here as a H, and if it is a ketone then we can write this as a, here it is R and then it is CH3 or another group also. So this is the structure of aldehydes and ketones. Now let's see that in this structure we know that is oxygen, which is electronegative in nature. So oxygen is electronegative in nature, that's why oxygen will acquire partial negative charge and this carbon will acquire partial positive charge. Similarly we can study here also, this oxygen will acquire partial negative charge and this one will acquire partial positive charge. So as we know student, this carbon is attached to the double bond with double bond and with oxygen, and that's why aldehydes and ketones are considered as very reactive groups. So let's start with the chemical properties of aldehydes and ketones. So first we are going to study about nucleophilic addition reaction. Nucleophilic addition reactions of aldehyde and ketone. Nucleophilic addition reactions of aldehydes and ketones, okay, or simply nucleophilic addition reaction. So student, we know very well that here if I'll draw the structure of carbonyl compound, so in carbonyl compound this oxygen will acquire partial negative charge, this one will acquire partial positive charge, and we know that this bond is polar in nature, and as this bond is polar in nature, that's why aldehydes and ketones are very reactive in nature. Now let's understand the mechanism of nucleophilic addition reaction. So here I am writing as, okay, so here I am taking this as this one is carbonyl group, this is carbonyl group. Now in carbonyl group, when there is a attack of nucleophile, and here negative and positive, so definitely this nucleophile will do attack on carbon and they will form as a transition state there. How it can form transition state? Nucleophile, and as carbon is bounded with oxygen with double bond, so this bond we can make it as a dotted to show the transition state of that particular group, that is transition state. And when it is in a transition state, and we know that transition state is not a stable state, and that's why after in this transition state, when we will add acid, in the presence of acid, that is H plus ion, how it can occur? It will occur this nucleophilic addition reaction in this way. First of all, or rather than writing it directly, I'll say that this transition state will first convert it into, this bond would be taken by oxygen, and then here it becomes in this way, that is nucleophile, and when there is a addition of H plus ion, we can see that there is formation of desired product. Formation of desired product, nucleophile, and it becomes OH. So whenever nucleophilic addition reaction is there, so we can see that the carbonyl group will do reaction in this way. Now let's understand the mechanism of this reaction one more time. Now this is the carbonyl group. In this carbonyl group, carbon is acquiring partial positive charge, oxygen is acquiring partial negative charge. when there is an attack of nucleophile will do attack on carbon, which is positive in nature. So when it will do attack on this carbon, there will be formation of transition state. It can form a transition state in this way, and as we know that transition state is not a stable. So this transition state will convert itself into this anionic form. When it will convert it into this anionic form and addition of H plus to it, we can get the desired product of it. Okay, so student, afterwards or in next class we are going to study that how this. Okay, let me give you one example also for this, so it would be easy for you to understand. Now if I am having CH3C H double bond CHO, that one is aldehyde. Okay, it is a aldehyde. When there is a attack of HCN from HCN take out nucleophile and that becomes CN negative. Now CN negative will do attack on this carbon, and rather than writing its complete mechanism, that is a transition and that transition state, directly we can write product also, and according to this product would be CH3, here it is H, then here let's see, one is CN negative and here it becomes OH. So in this way these aldehydes and ketones, that is carbonyl group, undergoes nucleophilic addition reaction. We are going to add the nucleophile in the carbonyl compound. I hope you understood this. Let's see that as we have aldehydes and ketones, we have aldehydes and ketones. So let's see that out of aldehydes and ketones, who will give or who can easily undergo nucleophilic addition reactions. So let me tell you that aldehydes are, here I will write aldehydes are more reactive. Aldehydes are more reactive than ketones. Aldehydes are more reactive than ketones. So here we will say that, and what all reasons for that. So aldehydes are more reactive than ketones. Why we are saying this? Because first let's take the first factor and compare between a simple aldehyde and a ketone. Now if I will compare between the simple aldehyde and ketone, I can see that on ketone there is a presence of two methyl groups. There is a presence of two methyl group in ketones. Here there is a presence of two methyl group in ketones, and in aldehyde only one methyl group is there. So due to the steric factor, so what will happen here? Steric factor, or I will write it as a steric hindrance. Steric hindrance is more. Steric hindrance is more in condition of ketones, and in aldehydes that steric hindrance is less. Now how this steric hindrance is related to the reactivity. So see that student, here is what here on this carbon partial positive charge is there, partial negative charge. Now due to presence of more number of methyl group, and these methyl groups are having tendency, methyl group, and this methyl group is having tendency, and that tendency is plus I effect, and plus I effect, it means what? It's a electron releasing effect. Electron releasing effect. So when these two methyl group will increases the electron density on this carbonyl carbon, so what will happen? They actually reduces the polarity, and if the polarity will reduce, their reactivity will also reduce. So here what concept we have studied? Why aldehydes are more reactive than ketones? First one is due to steric hindrance. And how we can explain this steric hindrance? We will say that due to steric hindrance, ketones, due to steric factor, as well as another one due to electronic factor. Now let's see that what is this steric factor and electronic factor. Now steric factor means what? Steric factor, it means due to presence of more number of this methyl group, more number of electron releasing groups, more number of electron releasing group due to presence of more number of electron releasing group, polar nature decreases. Polar nature decreases, and as the polar nature will decrease, automatically reactivity will also decreases. Reactivity will also decreases, and in electronic factor it means due to plus I effect. So here we are saying that aldehydes are more reactive than ketone due to steric factor and electronic factor. Now if I am having example as propanol and benzaldehyde. If I am having propanol and benzaldehyde, so I will say that propanol is more reactive than benzaldehyde. What reason I can give? I will say that yes, propanol is more reactive than benzaldehyde due to presence of steric factor as well as electronic factor. How can I explain steric factor? Simply I will say that on propanol CH3, CH2, CH2, then here it becomes CHO, and benzaldehyde it means here it is CHO. Okay, so when we will compare between aldehyde and aliphatic aldehyde, it is aliphatic aldehyde and aromatic aldehyde. So out of aliphatic and aromatic aldehyde, we can observe that aliphatic aldehyde are more reactive towards the nucleophilic substitution reaction. And why they are more reactive? Because due to presence of this group. Here only 2 carbons are involved with CHO group, but when we will observe this one, with this a complete phenyl group is attached, and here we have ethyl group, and here we have a phenyl group attached to it, and so that we will say that yes, propanol is more reactive towards nucleophilic substitution reaction as compared to benzaldehyde. Students, I hope you understood today's topic. Thank you students, and have a good day ahead.